What you're looking at here is a sort of a high view of the MechMate CNC router that I will be using for cutting the flat forms as well as plotting out the blanks for the flaps and the aileron ribs. So dropping down and taking a little closer look at what's going on here. Actually, you'll see right here where I've already gone ahead and done a test plot just using a plotter pin adapter that I have that works inside the spindle to be able to verify that the dimensions, that I do have the dimensions set up correctly for the G-code that was generated, and also it gives me an opportunity to verify that nothing has changed as far as the calibration of the CNC router itself, which after the check, of course, everything checked out just fine. So right now I've got a 1/4 inch router bit loaded in. We're set up to now try and cut a rib on the MechMate. I've already cut one. We're going to go ahead and get the other one cut. And it could get a little noisy. Probably will fast forward it some, since after the first few seconds, probably watching a CNC router cut a piece of wood is about as exciting as watching paint dry. What you're seeing is the final results for cutting the flap ribs. I've already checked the dimensions and everything is well within tolerance, easily within a millimeter. The next step we've got to do here, there's still some post-processing operations we have to do here. The first thing we've got to do is we have to put a rounded over edge, because essentially the way these forms will work, we'll place a sheet of aluminum in between these two and clamp this together. But of course we don't want a perfectly sharp edge right here. We want to have approximately an 1/8 inch radius or 1/4 inch diameter rollover on that. So that will be the next step. I'm now getting ready to go ahead and plot out the outline for the flat rib form. I've already plotted one out here. I'm going to go ahead and plot out a second one. I'm probably not going to plot out all of these. Instead, what I'm going to do, since this is a fairly simple shape, is I'm going to use one as a template and another one I'm going to use as my test piece. So this one of the two will be the template, and I'm getting ready to plot my second one right now. And as far as the pin itself, this is something that I custom built. It's designed to fit inside of I think it's a 1/2 inch ER20 collet, and this particular pin, the way it was shaped, it had a taper in it, so I was able to machine out a corresponding taper so that I've got a slip fit into it. Unfortunately, there's not any more. They don't make this particular style of pin anymore. I'd had some thoughts of maybe going ahead and offering some of these for sale, but since this particular style of pin with a tapered barrel on it isn't available anymore, this is sort of like one of a kind. So we'll go ahead and get set up. And the reason I keep jumping is I keep bumping into my little remote control pendant. So we've got everything set up at this point. We'll zoom this out. And I'm going to let this one just plot all the way through, because this will be a fairly quick plot, probably not more than a minute. So we'll go ahead and get started. It does a brief pause here because of the way the G-code is set up. It thinks it's trying to spin up the router, but of course for a pin it's going to be 0 RPM, but it still goes through this 10-second delay. What it's drawing right now is the center line locations for where the dowel pin holes would go. And that concludes the plotting. What we're looking at here is the final result of the plot. I've got two examples right here, and I continued working on my flat form as well. And this is essentially how the flat form will rest with respect to the blank itself. And then also this is the remade version of the skin flap, which as far as the results, I got a little bit of a change as far as the overall dimensions. It still wasn't quite what I was looking for. The fit of this still isn't quite as good as what I was hoping to see on this back end here, but I decided I'm going to go ahead and roll with what I've got and see what happens. Just for any reason, there's always a little bit of flexibility with the sheet metal, so even if everything isn't like dead on, there's quite often a good chance that even if it's not perfect, you can go ahead and sort of force things around a little bit and get it to fit and still get good results. So I will go ahead and start working on getting these trimmed out, and after that I will go ahead and demonstrate. There's still more work to be done on this on the flat form itself. There are some bevels that need to be cut, a rounded over edge that needs to be added in, and that will get covered as well. So the trimming's been done at this point, and the next step is I've got to put some holes in a couple of different places. One is for obviously the dowel pins, and then also in these corners I need to place 1/4 inch holes. So the tool I'm going to use for this is called a centering optical center punch. And essentially what this is, and I demonstrated this on another video, but essentially what this is you've got a little holder, and then you've got what's essentially a small lens that you can drop down to center over, and then once you've gotten centered over, then you'll use this punch. I don't know if you really see it in the video or not. Yeah, I guess you can. There's a little crosshair right there. So what I'll do is I'll drop that inside here, and of course I really can't give you a view inside, but I will get lined up over my hole and pull that out, drop my pin in, and just give it a good tap with a hammer. And then what that gives me is a nice little indentation I can center on. There's a couple of ways you can do the holes. One way, of course, is to use a drill, but actually what I'm going to use in this case is that I have a 1/4 inch punch, hole punch that I'm going to use. So I'll go ahead and get the rest of these holes marked, and then we'll go over to the center punch and go ahead and punch those holes out. What we're going to do next is go ahead and punch the holes in the blank that I've got here. Actually, of course, I've got two blanks, so actually one of these I'm going to reserve as a template for making additional ones manually instead of having to always go to the CNC machine. The CNC machine, of course, does have its uses, but sometimes manual methods can be a little bit faster. So my sort of in-between solution is if I've got a lot to make of the same type, I'll make like a test piece and then make a template piece so that I can make additional ones as needed. So on this one, I mean, I will
do 1/4 inch holes, but actually on this one I'm going to probably drill out to just a 3/32. So when I draw my outline, then all I have to do is just put a little dot in there, and then I'll use that to create the indentation when I use the optical center punch. So on this one, you won't be able to see it from here, but I'll do a second shot. There is a little indentation on the punch itself that I'll line up my little indentation on so that I'm centered up properly. And I'll show a couple of views of this. We'll go ahead and just do sort of a long shot here. So we're centered up on the hole, drop it down, and of course we've got one completed hole. And we'll go ahead and do the other one, or do another one. So what I'll do now is I'll set up for a little bit closer shot so you can actually see the punch in action. We're set up with a little bit closer view of what's going on with the punch. If you look down, you can see the punch, and if you look real careful, right about in there, you'll see the little dimple. So what we'll go ahead and do is get lined up on the dimple, and we're on there, and then just drop it down. Now, of course, one thing to point out is you don't have to have, obviously, a big fancy punch like this one. I also have one of the cheaper import handheld models, and those work just fine as well. I'm just using this one because this just happened to be what was close by. So we'll go ahead and get this last one done, and that takes care of that. Now, even though I did use the optical center punch, there's probably a good chance that I'm still going to be off just a little bit on my doweling, so I won't be too surprised if I don't have to maybe come back in with maybe a drill bit that's a 64th inch or even a 32nd inch, a little bit larger, just to make sure that everything fits over the dowel pins properly. So what I was sort of afraid could happen did happen. Actually, it happened in two different ways. I mean, actually the hole alignments look pretty good, but I'm not sure, for some reason my hole isn't quite 1/4 inch, either that or these dowels are maybe not like perfectly round, so I will have to go in with at least a 64th inch larger bit and go ahead and try and get this enlarged a little bit. So I did a little bit more investigation just to try and figure out exactly why this is not fitting over my hole properly. First thing I thought was, well, maybe I had a slightly different, slightly smaller punch inserted. Took a measurement with my calipers, and it was like dead on 250. So then the next step would be to go ahead and take a quick measurement and see what this shows. This actually shows about 249. So that really isn't the problem. So the only thing I can figure is maybe the metal stretched a little bit. I've got a 1/4 inch drill bit right here, and it obviously doesn't go through. So we'll go ahead and drill this out with the regular 1/4 inch drill bit, check the fit, and then if that doesn't work, then I've got the next size up in 64th, and we'll see how that goes. And regular 1/4 inch still doesn't quite get it, so we'll go ahead and try 17/64. See if that gives us enough clearance. I'm removing a little bit of metal that time. Probably should be wearing my safety glasses. And now we're fitting on there. There's a little bit of slop there, but it's more than acceptable. We're not gonna have any big issues as far as measurement. And then of course the other side of the form will fit on here, and of course I've still got to do more trimming here, and in addition there's still post-processing that I've got to do on this on the forming block itself, which is what we'll get into next. The next step is to go ahead and start rounding over the edges on the forms, and also we have to cut a 15-degree bevel. In fact, you'll see sort of off here in the corner is the sander that I'll use for doing the bevel, but the first thing you want to do before you actually do the bevel is actually round over the corners. Now the specification is that it's an 1/8 inch radius, 1/4 inch diameter, so what I've got inside here is a round over bit with a ball bearing on it, and of course the form will ride up against that bearing, and then the cutter will actually put the round over on there. Now, this is one area where it's definitely very easy to get things backwards. And you definitely want to make sure that you've got every possible orientation annotated. So, I've explicitly marked outside, outside, inside, and inside. And of course, you still have to remember that, you want inside down, because when you're actually bending the metal, it's going to be coming over this way. So hopefully in the course of doing this, I don't get distracted because I'm actually videoing this and you get to see me do this backwards. So go ahead and get this set up. This is going to get quite noisy, and I will actually be wearing hearing protection and, of course, safety goggles, and I'll also have my vacuum running. So we'll go ahead and get started. Okay, so we've got our round over done, and I don't know how easy it is to see, but we do have a slight radius on there. And the other thing is just go through, double check, make sure that I did hit all the areas, which there might actually be one spot right there that I've missed, so I'll have to go back and hit that again, and just inspecting the other one. Actually, if I got it backwards, it wouldn't be a big deal at this point, because obviously I could flip it over. Where you sort of hit the point of no return is that if you do your bevel and you get it backwards, then there's no way to take that back or try and do a do-over. So in the event there's any curiosity, what you're seeing is the setup that I'm using for the vacuum that I'll be using for both the router and also for the sander. Essentially just standard 14-gallon vacuum cleaner, and then on the right is a Dust Deputy vortex separator, which definitely comes in handy. It helps cut down on the clogging of the filter for the regular vacuum. Next step is to go ahead and bevel the edges of the form. The reason you need to do that, of course, is when you've got the piece of metal on here, if you just tried to bend it just straight down, there's always going to be a certain amount of spring back, so you actually have to have this edge beveled in just a bit further so you can get enough, so you can overbend the metal enough so that you get the 90 degrees that you're trying to shoot for. And of course, this is also the point where you do have to be a little careful, probably, or even more careful than on doing the round over, because if you get it backwards, then of course you basically have to remake the form, because there's no way to undo that. Now, one thing that you do want to have, and try and make sure that this is somewhat visible, you want to have some kind of witness marks on here to be able to match your progress, because you don't want to take your bevel all the way up to where you've got a sharp edge. You want to maintain that round over. So what you want to do is you want to put a set of witness marks in pencil. You don't want to use pen, because pen will absorb into the wood and you may wind up cutting more than you want. You won't be able to properly gauge your process, where the pencil lead will stay directly on the stay on the surface of the wood. And like I said, the goal is that basically this, you want to sand up to this first level right here. So we'll do our sanding. We'll keep an eye on this. In the course of sanding, it may actually be necessary to go ahead and redraw these marks a couple of times, because sometimes they'll just get sort of, I don't know, if they get covered in just sawdust, they become hard to see, or maybe the graphite gets sort of shaken off by the sanding process. But it may be necessary a few times to go ahead and just darken these lines up a little bit. So we'll go ahead and get set up here. It won't be quite as noisy as with the router, but still be a bit of noise because at the very least I have to have the vacuum going. So we'll get this going here and see what happens. And of course, big thing is, again, think about which way you want the metal to curve. So, you know, you've got inside mark, metal's inside here. We want to curve this way, so we want the bevel this way. So make sure that that side is down. And make sure I'm plugged in. Assuming you can hear me. Already made some. Okay, so this is the purpose of having the bevel marks on here so you can track your progress. If you look more on, try and get this centered up in the camera, more on here, we've got, you know, definitely getting some cutting in, still seeing some pencil mark there, so we got a ways to go. But then as you move further down, it's not too hard to tell that I've been putting more pressure on the opposite corner than on this corner, so I need to make sure that I'm putting a little bit more effort into this side here. Alright, so we've gone ahead and gotten this edge pretty well cleaned up now. Got a little bit of pencil mark still left, but most of them are pretty much cleared, so I don't think I want to push my luck. Again, of course, it doesn't have to be like exactly dead on, but it's got to be pretty close. And as far as edge on view goes, if I can figure out how to get things oriented, we're looking pretty good there. So I'll go ahead and complete these other sides. It's just more of the same thing, and we will continue on. One thing to point out, of course, probably most people are not going to have access to a CNC router for you know, cutting these rib forms, and instead they'll be creating them by hand. The normal procedure when you don't have a CNC router is that you would make one of these and use this as your template, and then you would rough cut a second piece, and then what you would use is, instead of a round over bit, you would insert a flush cutting bit, and then you would just run the have your alignment, you would have your alignment dowels set up so that these are together, and then using the flush cutting bit, you would run both of these together, and of course your original would then actually result in the second part, or the second form, being flush cut to match the same size. The details on that, if you're really serious about building your own aircraft, you need to take a look at the Home Built Help series. That has a lot of great introductory information if you're if you're really considering going ahead and making your own scratch-built aircraft. It's a great place to start and has lots of little tips like that. Beveling is completed now, and no major mishaps of that as far as I can tell so far. So next step is to go ahead, we would put that on and then fit this on, and then we can go ahead, well actually I've got to do a little bit more trimming right here in a few spots, but after I get that trimming done, then I go ahead and hammer this part down. Which for this is actually pretty straightforward. I mean, it's all flat, unlike say like a nose rib where you've got a lot of curves, and I would actually, in that case, have to add some flutes. Actually, the case of producing the nose ribs, I've actually covered some of that in some other videos. But in this case, since we're talking straight profile, of course, there's no need for flutes. So I will go ahead and get things set up for hammering. Or at this point, I'll go ahead and get these hammered down. Probably will not show the video for that, just because I've covered a more complex case in a different video, and there's really not much to see. This is a fairly straightforward operation because they're all straight surfaces.